So today I'm going to be teaching you how to do sequences. So what is a sequence? Well, let's take this one for example, 2, 4, 6, 8, 10. Well, this is considered as a sequence, and the reason is because each number you add 2 to get the next number. So you can see from here to here, from here to here you add 2. Same from 4 to 6 you add 2, 6 to 8 add 2, and 8 to 10 you add 2. And this type of sequence is called an arithmetic sequence, and the reason why is because it's, or you could call it a linear sequence, is because each term, so one of these are called a term, so this is the first term, the second term, the third term, and so on. So it's linear because each term has the same rule in between, so each term we add 2 like this, and so because we're adding 2, it's called a linear sequence because it's the same. But if, say for example, it's 2, then it's 4, then it's 6, adding each time, that would be a different sequence. That would be called geometric. So we're not going to move on to geometric, we're just going to look at linear today. So this rule that I'm going on about, is they call it the nth term rule, like so. And what that means is it's some sort of algebraic expression that shows us how we can get from one term to another, and it's usually represented as a number followed by n plus or minus, it could be, followed by another number. So let's call the first number a and the second number b. We don't know what they are, but we can work them out. So let's take this example that we had before. So 2 to the power of 2, 4, 6, 8. 2, 4, 6, 8, 10. And we said that from each one to the next, we add 2. And whenever your difference, so this is called the primary difference, you could call it the first difference. Whenever your first difference is the same, it will be a linear sequence. So if it's the same, you would say it's a linear sequence. And also the first difference is also important in trying to find the value of a in the nth term. So here, where we have a would be whatever your first difference is. So in this case it's 2. So a in this case would be equal to 2. So now that we know the difference, we can say the nth term equals 2. We're replacing the a with the 2, followed by an n plus b. Now we need to work out what b is. So we're saying we got a multiple of 2, and then we're adding this b onto it. So how can we work that out? Well, let's create a table, like so. And we say this is n, this is 2n, and then this will be 2n plus b. So if we take each value that we have, now n just represents the position of the number. So here 2 would be the first position, 4 would be the second position, 6 would be the third position, and so on. So n just represents the position number. So let me just write that down. So n is the position of the number, or the term you could say. So in our first position we have a 2. So in our first position we have 1. So 2 times n, which is 1. So 2 times 1 gives us 2. Then we have the second and the third and the fourth and so on, like that. So 2 times 2 now would be 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And what we have here, so at the top here, we have 2, 4, 6, 8, 10. Now we have to compare that with what we have here. Is that any different to what we have at the top? No. So if it's not different, then that means our b here is going to be 0. Because we're not adding anything to this 2n to give the same as what we have up here. So let me give you an example where you might have something plus b. So let's say we have 3, 7, 11, 15, 19. So first we need to see what our difference is. So our difference between the first and the second is plus 4. Second and third is also plus 4, plus 4, plus 4. So this will be our first difference. And because it's all the same, we know it's linear. And remember, this first difference will equal our a if it's linear. So a is going to be 4. So our nth term so far will be 4n plus b. And now we're going to see how do we get from here to what we have up here. So let's draw out our table. So n, this time it's going to be 4n, and then it's going to be 4n plus b. So we draw it out this. So we've got n is 1, 2, 3, 4, 5, because that's the positions of the numbers. So we have 5 numbers. That's why we put 1, 2, 3, 4, 5. And then 4n, so we're going to do 4 times 1 gives us 4. 4 times 2 gives us 8. 4 times 3 gives us 12. 4 times 4 gives us 16. 4 times 5 gives us 20. And so this row here usually represents what we have at the top. So we have 3 here, we have 7 here, 11 here, 15 here, and 19 here. And to work out what b is, we have to see the difference between the 4n here and this 4n plus b here, because the only difference between these two rows is the plus b. So if we're going to work out what the plus b is, we have to see how do we get from 4, so the top row, to the second row like this. And there should be a common difference between them. So we can see, because it's plus b, it's usually going to be a plus or a minus that you're going to be doing. You're never going to be timesing anything. So to get from 4 to 3, you're subtracting 1. To get from 8 to 7, you're subtracting 1. 12 to 11, subtracting 1. And you can see the pattern that it's always subtracting 1. That means our b is going to equal minus 1. So therefore, our nth term will be 4n. And because instead of putting plus b, we're going to put b, which is minus 1. So it'd be plus minus 1, but that's the same as saying minus 1. So this will be our nth term. Another way of working out how you can get the plus b section, so let's do our original equation here, sequence. 3, 7, 11, 15, 19. And we said that the difference between each one is plus 4. And so what we're going to do here is, so we said that this is the first term, this is the second term, third term, and so on. So now we're going to find the 0th term. And how we do that is to go in the opposite direction. So instead of adding 4 from 3, we're going to take away 4 to go in the opposite direction. So 3 take away 4 gives us minus 1. And this is equal to b. So you can see here how we got the minus 1 for b. So if I give you another example for you to do by yourself. So let's say we had 4, 7, 10, 13, 16. I want you to work out the nth term of the sequence. So pause the video, have a go, and come back to check your answer. So what you should have got is something like this. So this is how you would work it out. So what you do first is find the difference between each one. So here's plus 3, plus 3, plus 3, plus 3. So we know this is linear. Next, if you know it's linear, we know that A is going to be the same number as your first difference. So this, in this case, is 3. So our nth term so far is going to be 3n plus b. Now there's two ways of working out b. So the easier way is to go backwards. So if 4 was our first term, we want to work out the 0th term. So we're going to go backwards. So instead of adding 3, we're going to take away 3. So that will give us 1. So in this case, b equals 1. So that means our nth term equals 3n plus 1. Another way you can work it out is by doing the table method. So we put n, then we put 3n because the difference between each term is 3, and then we do 3n plus b, which will be the original sequence that we have. So we draw our table out. One, 2, 3, 4, 5, the positions of each term. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15. And then our original one, we said it was 4, 7, 10. So 4, 7, 10, 13, 16. And so to work out what b is, we have to find the difference between each term. So between the second and the third row, so this row and this row. So to get from here to here, like that. It should be the same for each number. So get to 3 to 4, we add 1. 6 to 7, we add 1. 9 to 10, we add 1. 12 to 13, we add 1. And 15 to 16, we add 1. So we can see the common thing is add 1. So that means b must equal 1. Therefore, our nth term will be 3n plus 1. So hopefully that made sense. The next part of the video will be showing you how to use this nth term to work out different numbers in the sequences. So for example, they might tell you to work out the 10th term of the sequence using the nth term.